Okay, so let us start the assignment for week 11. First question is match the table. The four options in the left hand side and four options in the right hand side. So first option I am writing the left hand side and then I will write the right hand side and we have to match which corresponds to what. So the first one is it is in the time domain and this is in the frequency domain. This is aperiodic and continuous. Next one is periodic and continuous. Third one is sampling and periodic. Fourth one is this aperiodic. Fourth option is sampling and periodic. Okay. Now starting the right hand side. Sample coefficients means like what I exactly mean is Fourier series periodic continuous frequency, that is DTFT. Option C is DFT and D is aperiodic and continuous. So we have to find which corresponds to what in the time domain and frequency domain. So let, let me tell you, discuss it. I think that is a periodic in time domain and it is continuous. Is also a periodic in the frequency domain. This is Fourier transform. So the first one, aperiodic and continuous, is also aperiodic and continuous. So the option is 2A. Now something is periodic and continuous in time domain. So periodic signal but continuous in time domain, then it always have a Fourier series representation. This is the rule of Fourier series. So it has particular coefficients in frequency. Because it is periodic, it will be discrete in the frequency domain and it will have only coefficients in the frequency domain, which is the particular frequency of that particular uh, time domain signal. So sorry, it was D. This is A. Now 3 is sampling and aperiodic. So we particularly do sampling in the time domain, but the signal is aperiodic. So as we are doing the sampling it here, it will be periodic and also continuous in the frequency domain. So this one is this. So this is actually DTFT. Option B. And if it is sampled and periodic in the time domain, it will also be sampled and periodic in the frequency domain. So that is also discrete and periodic in the frequency domain. So that is actually DFT. That is C. So this is the relationship between this time domain and frequency domain. So basically, if there is something that is aperiodic and continuous, it is also aperiodic and continuous in the frequency domain. Once we think about it is periodic. It is periodic. So periodicity in one domain just gives rise to the fact that it is sampled in the another domain. So, but it is continuous. So is the same thing. It is just gives the coefficient. So that is the basic thing, because it is periodic here, it is sampled here, and it has the particular coefficients as it is periodic. Because if it is periodic, that then there only exists some particular frequency components, and those frequency components are the sample coefficients. Similarly, it is it is sampled and aperiodic. In that case, what happens? It is sampled, but it is actually not periodic. So, in that case, what happens? It will be periodic, but it will be continuous in the frequency domain, because it is sampled here. That corresponds to periodicity nature. Okay, and if it is sample and periodic, then it is also sample and periodic. So it's actually sample and periodic. So this is the relationship actually. Okay. Okay, now let us go to the next question. The next question is, if the DTFT of a discrete time signal x of n is x of e to the power j omega, then the DTFT of x of n minus 2 is what? Okay, so just let me solve it. So if x of n is real, then f of x n star is equal to x of n. So if we do the DTFT here, that becomes x of e to the power minus j omega conjugate is x of e to the power j omega. We just save it as equation number 1. Uh, a little bit. I was just solving different things. Pardon for that. So if xn has a DTFT, that is x of e to the power j omega, then x of n minus 2, same DTFT, that is a time shift that will be reflected by phase shift here, that is the same x e to the power j omega, but with a particular phase shift of e to the power minus j omega 2. Just write this omega as this because this is the discrete time sequence. So this is just the same frequency domain representation with a phase shift of j omega 2. This is the right option. Now let us go to the next question. For x of n is equal to 2 to the power n u of n, find the discrete time Fourier transform. Okay. Just solve this one too. So, of n is 2 to the power n u of n. So from the properties, we know that it is a to the power n u of n format. So the corresponding Fourier transform is discrete time Fourier transformation is 1 by 1 minus a to the power minus j omega. So right here the value of a is 2. So if we do the DTFT, it will become 1 by 1 minus 2 for substituting a 2 e to the power minus j omega. So this is the answer. Okay. Now let us go to the question number 4. So we are giving a sequence x of n is a to the power mod n, and from this we have to determine x of e j omega is what. So just let us solve this. First, we just writing the signal is x of n, right? And this is actually e to the power mod n. That is what? If I write it, it is e to the power n for n greater than equal to 0 and e to the power minus n for n less than 0. This is the simplified form of xn. So x of e j omega, this will be for n equal to 0 to infinite a to the power n into e to the power minus j omega n plus n equal to minus infinite, another sequence for n equal to minus infinite to minus 1. It is from 0 to infinite and it is from minus infinite to 1. We are writing in that sequence, and for this it is a e to the power j omega to the power minus n. Okay, so that is also can be written as n equals to 0 to infinite a to the power a into, sorry, a to the power minus j omega into 1 to the power n plus n equal to minus infinite to minus 1 a to the power j omega to the power minus n. So this is also infinite sum and this is also infinite sum. From this we can write then with the GP series. So sum of the terms in the GP series. And for that we know this is a by 1 minus r in that format. So from this equation x e to the power j omega, we can write this one, the first one, as 1 by 1 minus a e to the power minus j omega. And the second one is a e to the power j omega 1 minus a e to the power j omega. Because in the first term it was 0 and it starts from 1. So if we solve this, let's multiply this two term in the different direction. So this is 1 minus a e to the power j omega plus a e to the power j omega minus a square, because this minus j omega term and this j omega terms cancels out, by 1 minus a e to the power minus j omega 1 minus a e to the power j omega. So more simplification form, we can write it as this, is equal to 1 minus a square by 1 plus a square minus a e to the power j omega minus e to the power minus j omega. Just multiplying this denominator terms. So what happens? It is actually 1 minus a to the power j omega minus a e to the power j omega. This is minus j omega, and another term is a e to the power a square. This is the denominator term. That form is simplified here like this. So this is actually equivalent to 1 minus a square by 1 plus a square minus a, and this is actually the value of cos of omega. So 2 cos of omega actually, because this is cos plus j sin omega plus cos minus j sin omega. So j sin omega terms cancels out and it becomes 2 cos omega. So the solution is actually 1 minus a square by 1 plus a square minus 2a cos of omega. Okay, so let us go to the next question. Question number 5. Question number 5 is we are giving x of n a sequence that is equals to the value 1 for the interval of mod of n less than equal to n and 0 otherwise. So again we have to find what is x e j omega. So x of e j omega is actually writing n is equal to from minus n1, just write it n, we write it n1 to n1 x of n to the power minus j omega n. So this is equivalent to write it in the following way. Summation is from n equal to 0 to 2n1. The values are 1 here. So 1 into e to the power minus j omega into p minus n1, where p is the value substituted with like this. Just we are changing the variable here, like p is n plus n1. We just substitute the variable here from n to p with this relationship. So again, this is sum of 2n plus 1 terms in a GP series. That is a 1 minus r to the power 2n plus 1 by 1 minus r. Equivalently, if we write it in this way, x of e j omega equals to e to the power j omega n1 into 1 minus e to the power minus j omega to n1 plus 1 by 1 minus e to the power minus j omega. So again, if we rearrange it like this, it's actually big rearrangement is e to the power this equal to j omega n1 into this inside term we are just writing it as e to the power minus j omega now we are taking a term common plus half. This term we are taking as the common term, so this becomes e to the power j omega n1 plus half, and from this term it becomes e to the power minus j omega n1 plus half. By the similar way, just can write e to the power minus j omega by 2 term common, and it becomes e to the power j omega by 2 minus e to the power minus j omega by 2. So again, if this n1 terms goes inside, what happens? This n1 terms and this n1 term cancels out. So with this multiplication, this factor, this value becomes, this multiplication value becomes e to the power minus j omega by 2. And this e to the power minus j omega by 2 and this e to the power minus j omega by 2 cancels out. So for simplicity, just let me write it once. So basically, if I take this whole term as variable big M, so it becomes e to the power minus j omega by 2 by e to the power minus j omega by 2 into M, and these two cancels out, so it becomes M. So this is the term that remains. Okay. So just let me write this once again. What the term remains is x of ej omega equals to e to the power j omega n1 plus half minus e to the power minus j omega. This will be equivalent to e to the power j omega n1 plus half minus e to the power minus j omega n1 plus half by e to the power j omega by 2 minus e to the power minus j omega by 2. So this is actually a sine term and this is actually also a sine term from the Euler's equations. So this becomes 2j sine of omega n plus half by 2j sine of omega by 2. So these two cancels out. The answer is sine of omega n1 plus by sine of omega. So these two terms cancels out and this is the answer. Okay, so now let us go to the question number 6. So a discrete time signal, that is x of n, has a DTFT of xe j omega. So we need to find out what is x of n in this case. For if the write it if the DTFT is x of e j of omega minus omega 0. If this is the DTFT, then what is x of n? That is the question. Okay. So this is actually the comes from the frequency shifting property. So what it tells is that if we have a discrete time sequence that is x of n, that becomes x of e j omega. Similarly, for x of n e to the power minus j omega 0 n if we multiply by this particular frequency, it becomes x of e j omega minus omega 0. So this is the frequency shift. So the answer is here. This is actually x of n into a frequency shift property omega 0 n. So this is the change. Okay, now let us go to the next question. The next question is, if we have x of n equal to del of n plus 3 plus del of n minus 3, then what is x e j omega? So we know that if it is a signal that del of n, that is Kronecker delta function, then del of n has a DTFT of 1. Now, if we say what is del of n by a frequency of time shift, it becomes what? It becomes e to the power j 3 omega. Similarly, if we do a time shift by n minus 3, it becomes e to the power minus j 3 omega. So x of e j omega, it is actually summation of these two terms, e to the power j 3 omega plus e to the power minus j 3 omega. That is actually cos 3 omega and multiplied by a factor of 2. This is the answer. Okay. So the last question for today. Question number 8. If x e j omega is purely real and even, then x of n is what? Imaginary and odd, option B. Real and even, C is imaginary and even. Option D is real and odd. So let's solve this. If xn is real, then what happens? X of n star is equal to x of n. So if we think about the DTFT counterpart of them, it is equal to x of e to the power minus j omega. The star is equivalent to x of e to the power j omega. This is equation number 1. So now if it is even, if x of n is even, then x of n equal to x of minus n. Similarly, from the DTFT relationship, we can write the corresponding thing. X of e to the power minus j omega equals to x of e to the power j omega. From these properties, this is the DTFT relationship. And we denote it as equation number 2. So from these equations, this is also x e to j omega, this is also x e j omega. We can write x of e j omega star is equal to x of e j omega is equal to x of e to the minus j omega. So from this we can conclude that x of e j omega is purely real and it is also even because of this relationship. For this relationship, it is also Just write it. And even. All three relationships. The correct option is option B. So this was all for today. We will meet in the next Tuesday.